Okay, the last unit is acids and bases, and I want to just go through and talk about some of the properties of acids and bases, just some of the general things. First of all, acids generally taste sour. Anytime you have anything sour, like Sour Patch Kids or vinegar or anything like that, it's because it's an acid. Vinegar is an example of acetic acid, a 5% acetic acid solution. Sour Patch Kids, I think it's ascorbic acid that they put on there, but it's always some sort of an acid that will give you that sour taste. Bases taste bitter. If you've ever gotten soap in your mouth or anything like that, that is basic, and it has a very sour sort of a taste to it. Acids basically look like water. If you do get them into a cut, and some of you may have experienced this in lab, it'll burn. It's when you get stung a lot of times by insects or bitten by fire ants or things like that, a lot of times they're putting some formic acid or something into the wound to make it burn more and to irritate. Bases actually feel slippery. They hydrolyze the fats and oils in your skin to make a soapy-like material. Soap used to be made from the ashes of a fire and fat, and the ashes of the fire would be basic, and that would create soap. And basically, when you get a base on your skin, it's doing the same thing with the oils and things in your skin, which make your skin typically feel very dry after you've been exposed to some base. As far as reactions with metals, some of you have seen this in the lab or may remember things like magnesium. If you put them in hydrochloric acid, they bubble and they react pretty strongly. They produce hydrogen, which we oftentimes would collect, if you recall, in a large test tube, put a burning splint in there, and it would pop. It would ignite because we were making hydrogen. Bases generally do not react with metals. Acids are electrolytes in solutions, and so are bases. They both produce ions, and ions in solution allow water to conduct electricity. So they're both electrolytes. You oftentimes will look to see if you have an acid or base by using an indicator. Acid-base indicators generally turn one color in an acid and another color in a base. Oftentimes with certain kinds of paper, pH paper, you can blend several different indicators to get kind of a variety of colors, which will let you know if the pH is, they'll give you a number. Is it 7 or 9 or 8 or what have you? And we'll talk more about pH down the road. But litmus paper is one of the most common indicators. And when it turns red, when blue to red, it's acid. You'll see the D is capitalized because there's a mnemonic that says blue to red is acid. So if you ever end up with red litmus paper, it lets you know you have an acid. And base turns blue, so red to blue is base, and you'll notice the B is capitalized there. Another very common indicator is phenolphthalein. It is colorless in acid, but pink in base. It's very, very common in titrations, which are reactions where you react a known quantity of acid and base with each other to determine the concentration of one of them that you may not know. You don't need to know all that at the moment, but again, just phenolphthalein, very, very common indicator. I mentioned pH paper, which will give you a range of colors, which gives you a better idea of the actual pH. And of course, you can always use a pH meter, and a pH meter is simply something that it's an electrode basically that measures the concentration of ions in the solution, and then we'll give you a concentration and then a pH. And like I said, we'll talk more about pH down the road. Now, when you put an acid and a base together, they actually neutralize one another. And this will make a little more sense as we go through acid and base theories, but a neutralization reaction is, by definition, when the acid and base come together, they produce a salt and water. Now, when I say salt, that doesn't always mean sodium chloride. Now, two of the most common acids and bases are HCl and NaOH, which do indeed produce NaCl and H2O. But it's not always NaCl. It's any kind of an ionic compound where the positive, the cation from the base joins with the anion from the acid to give you an ionic compound or salt. Acids generally have an H at the beginning. That's a very common thing that you might want to start recognizing now. Bases generally have an OH at the end. And again, that's a very common thing that you'll see as we go along. So when the acid and the base come together, you might recognize this as a double replacement reaction. The Na joins with a Cl to give me NaCl. The H will combine with the OH to give me HOH or H2O, which is water. Now, one of the most common definitions of acids is the Arrhenius definition. This is one of the earliest. It was developed by a Swedish chemist, Svante Arrhenius. And he basically said that he defined an acid as something that dissociates in water, so it separates into its ions, and the H plus ion is produced by the acid. And an OH ion is produced by a base. So things like sodium hydroxide, calcium hydroxide would all be considered to be bases because they are ionic compounds. And they are electrolytes. They dissolve and produce OH ions in solution. A couple of problems with that definition is it restricts the definition to only acids and bases existing in water solution. And it simplifies a little bit what happens when acids dissolve in water, and we'll talk more about some of these definitions as we go along. It also did not include certain compounds that do allow OHs to be produced in solution, which again we'll talk about more down the road, but ammonia is one of them, NH3. So independently of one another, Bronsted and Lowry came up with a different definition that simply says an acid is a substance that donates an H+, and a base is something that accepts an H+. So you put HCl in water, it will produce H+ ions and Cl- ions, so that's an acid. The base, the ammonia, the NH3, in a solution will take an H+ from the water typically, or wherever it's coming from, to produce NH4+, but it's accepting the H, so then it can be considered a base. So there's some advantages to this definition. One is that acids and bases are defined independently of how they behave in water. It also focuses solely on what's happening with the H+ ion, the hydrogen ion. Please recognize that a hydrogen ion is the equivalent of a proton because a hydrogen atom has a proton and an electron. So H+ means it's lost that proton or lost the electron, so all that's left is that H+. Therefore, acids are oftentimes called proton donors, and bases are called proton acceptors. You're going to watch a video independent of this where we just define a little bit about what acids and bases are.